So we're going to start today with an example in which we're going to calculate the output of a digital logic function given that the inputs are tied directly to ones and zeros. In order to analyze a circuit like this, we really need to track the ones and zeros as they progress through the circuit and then consider what would be the output of each gate given the inputs that have been applied to it. So let's start from the far left. You can see here, if I first of all just think about what would be the output of this gate if it were just an AND gate. So I'm gonna look just before the bubble, just before the inverter. If I'm going to AND two numbers together, if I'm ANDing together 1 and 0, well, that's going to yield a 0 because it has to be 1 and 1 in order for that to be a 1. But of course, then once it gets inverted, then that means that this location is going to have a 1. And of course, the wire that connects that gate to the next gate is just going to faithfully transmit the signal that was applied to it. So a 1 will be applied to the input of the OR gate. Over here, I can do the same thing, and sort of an experienced digital logic engineer probably wouldn't go to the trouble of showing these intermediate results as I'm showing them at the before the bubble and after the bubble. But I think it really makes it easier, and especially when you're just learning these things, I think it's much easier. If I have 0 or 1, well, 0 or 1 is going to yield a 1. But then, of course, after I invert it, that's going to yield a 0, and that will be transmitted to here, and it will be transmitted to here. This gate is just an OR gate, and so if I have 1 or 0, that's going to yield a 1. An inverter is the easiest gate. 0 inverted becomes a 1. That means that I'm going to have a 1 here and a 1 here. And when I AND those two 1s together, that's the only possible combination in which an AND gate will yield a 1. And so therefore, F is equal to 1. And that's my final answer for this particular problem. One thing to observe is that if any of the 4 inputs, the 1, 0, 0, 1 on the far left, if any of those change, then it's possible that the output would change. So the analysis that we've done here is really only valid for this particular combination of inputs. As we're going to see in the next example, there's a better and more complete way of doing this analysis, but this is the first example for today's lesson.